manner. Or in other words, before Hadoop, all these things were being manually done by the developers when they dealt with big data. So developers have to first learn all the concepts of multi-node communication, process communication, threading, and all those things. Then only they were able to work with big data. Whereas today, Hadoop is simplifying it. Hadoop is automatically taking care of that. And we don't have to worry about it. It frees us from the task. In other words, if you want to drive a car, what do, Pratyusha?
You should be a mechanical engineer.
You don't have to be a mechanical engineer. You just turn the key.
Yeah.
So the Hadoop takes care of converting the petrol to electricity. In other words, it's taking care of the internal complexities. Cool?
Yeah.
Very good. Thank you, Pratyusha. A bunch of questions there. Thank you for working with me. And allow me to put you back on mute. Okay. So far, everything going well, Pratyusha? Are you able to follow me?
Yeah, everything is going on.
Very good. Very good. Thank you, Pratyusha. Good, guys. So that is Pratyusha, guys. I put you back on mute, Pratyusha. So let's come back. What is the difference between name node and namespace? We're coming there. I'm probably going to cover some of those concepts, Rajan. So just bear with me while we touch them. So today we'll get into a little bit of more of these things and see what we have here. Okay, so difference between traditional systems and Hadoop. Let's see what we got here. Okay, so here's what is happening, guys. Okay, in traditional architectures, what we did was we started using database. Then after database, we started, as our data started growing, we went ahead and we started using data warehouse. A data warehouse is nothing but a group of, data from a group of databases is plugged into a bigger or a super database that is referred as data warehouse. It is very expensive, or it is more expensive than a traditional database, and primarily used for reporting and things like that, guys. Okay. So what happened as the data started increasing? What did they do? We moved on to what is called MPP analytics. MPP stands for massively parallel processing analytics. In other words, that's where some parallel processing tools and software started coming in. And after that, as more and more data started coming in, came in the NoSQL. As NoSQL was coming in, that's where the Hadoop started picking up, guys. Okay. So what does that mean? We'll try to understand that in a bit, but let's move ahead a little here, guys. Okay. So what do we have? We're comparing the traditional system, which is primarily the database, versus Hadoop. Let us try to understand how, if Hadoop is a database or not. If it is not a database, what is the difference between Hadoop and a database is what we'll try to understand, guys. Okay. So let me do a little bit of cleanup. And what do we have? Well, the database. The database is, from a schema's perspective, it is required on write. What does that mean? Well, what that means is, imagine this is our database. For sake of simplicity, this is our database. And imagine we have a table called customer. And let's say we have an ID and a name. And let's say, for sake of simplicity, name can take up about 50 characters. But imagine now we are saving some data into this table. And let's say, come here, that's our row. That's a data that we are saving into the table. As we are saving that row, what does the database do? The database is verifying, hey, what is the length of the ID? What is the length of the name? Is it an integer? Is it a character? Is it a varchar? And things like that. Okay. It is also verifying length of it. Imagine we go ahead and give a name which is greater than 50 characters. What does it do? Well, it will not go ahead and save it. It will immediately reject it. It will stop there. In other words, what a database is doing is, at the time of writing the data, it is verifying the schema. What is the schema? What is the data type? What is the length? What is the other relationships and constraints and things like that? What is that? That is called schema on write. In other words, traditional databases are set as schema on write. We verify, we check the schema at the time of writing the data. Cool? Come to Hadoop. What happens in the world of Hadoop? It is schema is required on read. Now, schema on read is what it is. Read as or said as, guys. Okay. What does Hadoop do? Imagine we have some kind of data. Cool. What do? We take this data. We can just go ahead and load it onto Hadoop. What does it do? It will not verify anything. In other words, at the time we are writing it, it will not verify. At a later point, what will happen? Well, we have saved a lot of data. So now what we want to do is we want to do some rich analytics, some big data analytics and things like that. So what do? Well, that's where we come in. We start writing some code in Pig. Come here. Choose them. We'll start writing some code in Pig. Okay, what will happen? Let's say Pig, Hive, or Java MapReduce, guys. Okay, what happens is those tools will go ahead and generate some code. As they generate the code, what happens? Well, the code will move to the place where the data is, and it will start processing this data. As it starts processing the data, what it does is it goes ahead and reads the data, and at that time it is verifying based on our use case. That might be, textual data that we may have downloaded from Twitter, or maybe from some social networking sites and things like that. What we do, we read the data and we verify. Is it 50 characters? Do we have positive sentiment? Do we have negative sentiment? And things like that. In other words, what we are doing is we are verifying the schema at the time we are reading the data. In a database, at the time of saving the data, we are verifying. That's why it's called schema on write. In the world of Hadoop, at the time of reading the data, we are verifying the schema. That is why it is referred as schema on read. Okay, guys, that is one thing to keep in mind. Coming to a database, come back here. Speed. From a speed perspective, for a database, reads are fast. Why? In the world of database, what do? We deal with much smaller amounts of data. It's where we are at. Okay, we deal with maybe a few million rows of data in a database. So what do you have? Well, at the time of reading, we're able to get small amounts of data is one point. Second point, guys, at the time of reading, we don't verify the schema, so the reads will come real quick. Boom, boom, boom. They'll immediately come back, and we have a faster performance at the time of reading it. Okay. Whereas in the world of Hadoop, what happens is when we are writing the data, when we are saving the data, we are not doing any schema verification. So what happens is writes are fast. Okay. And what happens at the time of reading the data, when we write our Java MapReduce programs, Hive or Pig programs, at the time, what we're doing is that's when we are reading the data. So in other words, the reading is slow, writing is fast. From a speed perspective, guys, okay? Another one is governance. What is governance? At the time of building a database, we decide the complete entity model. What is the table? What is the child? What are the relationships? What are the constraints and things like that? So it's like when you're building a house, you go ahead and you plan everything. You come up with an architectural plan, and then you go ahead and build the house. Okay. So what is that? You're doing the governance. You're defining the standards, and you're saying, hey, this is how I want my drawing room to be structured and things like that. In other words, we go ahead and define our schema. So in other words, you design first, and then you save the data. What happens in the world of Hadoop? Well, you don't design it. What is Hadoop? Hadoop is like a go down. As you get your goods, you just go ahead and dump them there. You may have any kind of data. Just go ahead and plug it. First, load it up. Then, based on your orders that you're getting, you may get some orders from a supermarket saying that, hey, from the go down, I need maybe all the milk. So what do you do at that time? You come to the go down and you go ahead and get your products and things like that. Okay. So in other words, in Hadoop, we don't go ahead and design. We don't have to design. You'd have data first, save it there. Later, we can go ahead and design later. And that is what is called loosely structured. In other words, there is no structure at the time that we are defining at the time of saving the data, guys. Okay, that's from a governance perspective. Processing. In the world of database, we deal with limited data. We don't deal with big data. Databases are meant for much smaller amounts of data. Okay, what happens? You just get the data, and then you pass it from one server to another server, and the processing is done in other servers. That is what we mean by node processing. In the world of Hadoop, what is happening? Our code, as we write our code starts moving. Cool. Our code starts moving, from one server to the place where your data is, and it will get executed. If you remember the principle of data locality, guys, okay? We discussed about that. What is that? It is, in traditional architectures, the data is moving from one server to another server, whereas in the world of Hadoop, it is a code which moves from one server to another server. That is what we mean by processing is coupled with data. We move the processing to the data and we process it there, guys. Okay. Then comes the data types. What is data types? We define the structure before we start using the database. It's like, you're defining the structure of your house. What about your Hadoop? Again, it is go down. It is multi-structure. You can store any kinds of goods here, not just sofas, chairs, which are traditionally there in a house, but you can store different kinds of things. That is what we mean by multi and unstructured data. In a structured database, we generally store textual data, okay, textual, numeric data, and things like that, guys, okay? Whereas here, we may store audio data, we may store video data, we may store some other kinds of binary data here in the world of Hadoop. Cool, guys? Best fit. Database is best for OLAP, analytics, and transactions. What is transactions? Transactions is, let's say you go to Amazon. You type in you're ordering a product and they will ask you, please enter your name, your credit card number, address, and things like that. When we enter that, what's happening? Well, our data is getting saved into database, guys. Okay, what is that? That's a transaction. Transaction is something which we go ahead and update, delete, and things like that. At a later point, we may come back and we may change our address and things like that. That's a transaction. Okay, analytics. We do some analytics, not the analytics that we do is mostly the business intelligence, which is focusing more on the past is what is the analytics that we do in a database, guys. Okay, that is what is best fit for. It is best fit for saving, dealing with the transactions and doing the business intelligence. Whereas the world of Hadoop is about predictive analytics. You focus on the future. In the analytics world, in the business intelligence world, we focus on the past. Whereas in the world of big data and things like that, we focus on the future. What do? We try to discover what is about to happen. What is that? That is predictive analytics, guys. That's a touch of predictive analytics. We don't know what is about to happen. Here, you focus on what you already know. In the world of big data analytics, it will help us in focusing what we don't know. That is called discovery. We deal with different kinds of data. If you remember, that is the rivers of the world. This is the seas and oceans of the world. What do we have? Massive data. That's why we are referring it as big data, guys. Okay, gentlemen, ladies, I know there are too many arrows there, but is that making sense, guys? Everybody with me on this? Conceptually, could you just type in a quick Y or an N, guys? Are you okay with this slide? Cool. Okay, great. Okay, so that's a touch of some of the differences between database and Hadoop. And let's see what we have here. Big data technologies. Let's see what we have. Cool. Okay. So storage and management. What is HDFS, guys? HDFS can be thought of as the brain of Hadoop. I may have discussed this, guys. Okay. So what is HDFS? Let's come here. HDFS is a group of computers. These are, let's say, a group of computers, but they act like a single computer. Cool. They're a group of apartments in the ground floor. In your first floor, there is only one apartment. That apartment is, there are no walls in that. Okay, that is this apartment. Let's go and see. Get rid of that. How about select this one? And how about select this one? Let's say this is our office on top of all the apartments. And there are no walls there. What is that? That is HDFS. That is also referred as a brain. Why do we call it as a brain? Well, because imagine, come here, we can store different kinds of data. Or we can store, data is like the thoughts of a brain. This is different kinds of data. What data? Structured data, unstructured data. We may also store video data, other kinds of data, guys. Okay. So the data is like the thoughts. And what do we do with our thoughts? Well, that's where comes the map reduce, guys. Okay. So let's come here. Let's say this is map reduce. Come here. What is map reduce? Map reduce is the heart. Let me go ahead and come here. Select this one. Select this one. We'll call this as HDFS. We'll call this one as MapReduce. MapReduce. What is MapReduce? MapReduce is the heart. Okay, guys. Data is like the thoughts. What are we doing here? Well, here's what we're doing. We're going ahead and when we have thoughts in our brain, we read the thoughts, we analyze the thoughts, we process the thoughts. Okay. We read structured data. We may analyze structured or unstructured data. We may also process structured and unstructured data. How do we do that? That's where it comes in MapReduce. MapReduce is used for reading, analyzing, and processing, guys. Okay, what does our heart do? Imagine our heart is connecting to the brain, and our thoughts are in the brain. What are we doing with our thoughts? We are wrapping. We're doing wrap, read, analyze, and process our thoughts, and then we make decisions. What is good and things like that. Okay, but there is one problem with this one, guys. Okay, what is that? Well, if we work with MapReduce, we need to be expert in Java. We need to thoroughly understand MapReduce. We need to thoroughly understand, or we need to have an idea of object-oriented and function-oriented concepts. That's the problem. So what does Hadoop do? That's where it gives us two eyes. Okay, let's come here. Let's see what are the eyes. Let's select this one. This is one eye. Come here. Okay, what is that? Well, let's call it as pig. What does pig do? Pig will go ahead and take, come here, simple English-like commands as input. And what will it do internally? It will connect with MapReduce framework and generate Java MapReduce programs, guys. Okay, internally it will generate the Java MapReduce programs. In other words, we don't have to be an expert in Java MapReduce or object-oriented or function-oriented concepts. What is Pig doing? Pig is also doing a wrap. It's allowing us to do read, analyze, and process. But this time we don't have to be experts. In other words, it is reducing the complexity. We're able to work with big data, analyze and process the big data without really knowing the internal complexities of MapReduce, guys. Okay, what is it doing? Well, we're calling it as one of the eyes of the Hadoop, guys. Why? Because we're analyzing. What do we do with our eyes? We're looking at around the world. We're saying something is good. We are, we see something, we say, hey, something is good, something is neutral, something is bad, and things like that. Imagine your eyes are connecting to your brain, and imagine your eyes are connecting to your heart, and the heart is connecting to the brain and analyzing the thoughts. So that is what the eyes do, guys. They're analyzing. We have another eye. What is that? Well, that is what is your height. Cool. Come here and let's select them. Oops, let me come. Oh, I forgot to record that. Okay. See. Okay, so that is height. What does height do? Height is also going ahead and allowing us to wrap. Okay, we're doing wrap here. And how do you do that? Well, by using simple SQL commands. Internally, what does Hive do? Hive internally takes the SQL as input. It will connect to the Java, the MapReduce framework, and it will allow us to read, analyze, and process. That is the second eye. These are the two eyes of Hadoop, guys. Okay, so HDFS is the brain, and processing, processing is MapReduce. That is the heart, and Hadoop again. Okay, let me just play this. Let me just put this here. Hadoop again is a distributed file system. A distributed file system is your first floor. It's really a group of apartments. They act like a single apartment. And what is HBase? HBase is the stomach of Hadoop, guys. Okay, what does HBase do? Imagine, let's go ahead and come here. Let's choose this one. Let's put HBase like this. Here. What is HBase? HBase can be thought of as the stomach. Okay, or let's come here to be more precise. Here is HBase. It sits directly on top of HDFS, guys. Okay, let me do a little bit of clean up there and select that. Clean up there. Clean up there. Clean up there. Okay, so there is HBase. It is the stomach and it is the mouth of Hadoop. Why? We use our eyes to analyze the data. We use the stomach. We use the mouth to modify the data. That means Pig and Hive cannot be used for modification. If we need modification of data in Hadoop, it does not allow. But with HBase, we can modify the data. First point, right? When we take the food in our stomach, we're modifying it. So HBase allows us to modify it. That's why we call it a stomach. Another friendly way to remember it is also the stomach. Okay, I'm sorry. I'm backing up here. When we take the food in our mouth, we modify it, guys, okay? So if we want to modify the data in Hadoop, we can use HBase is one point. That is why we are calling it as the mouth. Second thing is, what is HBase? HBase is the database of Hadoop. Remember, Hadoop is not a database. Hadoop is a distributed file system, guys, okay? And distributed file system, we just said, a group of computers, they're acting like a single computer, guys. Okay. And why are we calling it stomach? Because it's a database. What does database do? Well, you give any data to it. What it will do is it will take the data and then it will internally store it in HDFS. Behind the scenes, it is storing in HDFS. So what's happening in our stomach? As we take the food, we are going ahead and storing our data inside the stomach. What is HBase doing? HBase is allowing us to store the data in another way. That's why we're also calling it as the stomach of the Hadoop, guys. Okay, everybody with me, guys? Is that making sense, guys, gentlemen, ladies? Cool. And we also have other connectors. We can also do statistical analysis for data science and machine learning and things like that using R and things like that. That's what that is. But let's have another quick look at these tools from another perspective. Okay, let's see what we have here. Those two are the eyes, guys. Mahout is a machine learning. The problem with Mahout is our friend Pratyusha looks like already touched Mahout. The problem with that is we need to have an idea of Java programming again. Whereas again, doing machine learning in Java is pretty complex, guys. Okay, so that is what Mahout is. It is used for machine learning on big data and using Java. It uses Java, and we have no Java, guys. Okay, and database integration. What is Scoop? Scoop is a tool which is used to transfer the data. From where? From database. From any database, we can use it to transfer the data into HDFS. Oozie is a workflow manager. Or in other words, it's a workflow management tool or a kind of a workflow tool where what happens is in real world, we write some scripts in Hive, we write some scripts in Pig. And what do? We want to take whatever is coming out of Hive, we want to go ahead and feed it to Pig. Then we want to go ahead, whatever is coming out of Pig and feed it to Scoop. Then we want to go ahead and connect to Scoop and get that and save it to another database. Okay, so what is that? All those things can be done one after one using something like Oozie. It's referred as a workflow management tool, guys. Okay, and then Cloudera Manager. It's a tool which is used for managing. It's more of an admin's friend, admin's tool. Cloudera Manager and Oozie are admin's friends, guys. Okay, mostly these two things are handled by the administrators in installing, or rather, that is used for installing and administering and monitoring purposes and things like that. Okay, so that's a quick touch of all the tools of Hadoop is what it is. Everybody okay with this one, guys? So Mahout is a machine learning tool. Machine learning is a slightly complex thing for me to simplify and explain to you, Srujan. But Mahout is a Java machine learning tool which is used for performing machine learning on big data on Hadoop. Short answer, if you will. Okay, Srujan? Cool, guys. Are you guys okay with this slide, guys? Cool. Okay, gentlemen, ladies, let's go ahead and get to our first round of this one, which is the labs. So let's go ahead and see what we have here today. There's a virtual machine, and come here. So control. Okay. Short and sweet. What you need to do, what we need to do. Just say VM player download. Click on that, and you can download this one, guys. VM Workstation, or whether it's for Windows or Linux, as simple as that. Once you install it, this will be valid for 30 days. But this is where we'll be going. Start, and then we'll go to all programs, right? These all programs here. See, once we install it, this is what you should be seeing. VMware. In here is VM Workstation Player. This is what I put here. Okay, we click on this one. Okay, once we click on that, this should open. And over here, there's a zip file that I would be sharing with you. Okay, so I'm probably gonna wait for a day or two to get a final confirmation of who's enrolled and not and things like that, guys. We need to follow that process just to make sure. And let me also show you how that file looks like. So, okay. KS_VM. Okay, let me share my screen now. Okay, see this, guys? This is a zip file that I will be sharing, KS_VM. What you need to do is you need to download that step 1. Step 2, you unzip it. That's how that will look. Step 3, go into that. That's how that will look. Okay. Then after you unzip it. So in other words, you download the zip file, you unzip it, guys. As simple as that. Nothing much complex there. Okay. And then you go to VM player, just say player, file, open. Go to the location where that is. So in this case, I already have it here. Okay, and right now I have it configured as 8 GB RAM. You can click on edit virtual machines. Right now, I think if you have even 2 GB RAM also, it will work, but a minimum of 4 GB is what I would suggest or advise, because 2 GB may be very, very slow. So right now, I can go ahead and change this. For me, I have up to 16 GB. So I have allocated about 8 GB RAM, guys, okay? So you can, let me go ahead and play. Okay, let me go ahead and play this one for a second. We'll give it a second here. Okay, now let's come here. And once I play, what I'm going to do is I'm going to go ahead and shut it down. Okay, this is a virtual machine, guys. On your Windows, it's acting like another Linux box, which is sitting in your thing. So let's come back. Oops. I think I need to come back here. Open the VM player. What I want to show you is once you shut it down, see that that's how that looks. And now edit virtual machine settings. Earlier it was not shut down, so these things were disabled, if you notice. Now I can change this one to 8 GB and 4 GB. So we need to shut it down so that we can adjust these things. I have adjusted it to use 2 processors and things like that, guys. So based on how much RAM you have, you try to play around and try to give it more RAM if possible, if you have more, guys, okay? Then after you adjust that, click on play. Cloudera Quick Start expire. No, Cloudera Quick Start will not expire, Srujan. If that's what you're looking, it shouldn't. It's a free one. Cool. But I think that requires more of RAM, minimum 8 GB or something like that. So that's the issue with that. Whereas this one will work even if you have 4 GB of RAM, guys. Okay. So let's give it a second. I'm just about to start this one. Okay, just making some adjustments of mine, guys. There you go. Okay, looks like it's almost there. So the password will be Hadoop 123, guys. I will share this zip file with you, and you need to download it. It's close to 4 GB or 6 GB, something like that, guys, approximately. But when you actually open it up, it will end up being 12 GB or something like that. So you need to have that one. So training is username. I'm going to log in here. The password is going to be Hadoop 123. Press enter. Give it a second. So if we were to, in real world, we were to go ahead and log into a Linux box, this is the same process, guys, okay? So now take a look at this one. You click on the terminal. This is like your command prompt in your Windows environment, guys, okay? So let's go ahead and say, zoom that in. Hope you're able to look at that better. And now there is something called places. So this is like our command line window, whereas places is like our Windows Explorer. You should see something called data, DS. Then there are a bunch of labs there. There is labs. And what do we do? Well, here are all our labs, guys. I've already plugged in all the labs and things like that. Let's go to the first one. Let's go to the new admin menu, and let's go and see some of the basic Linux commands and things like that. So the first thing is we're going to go ahead and say JPS. Okay. And when we say JPS, it means Java process. Show me the list of Java process. Why? Well, I'll explain that to you in a second. But before that one, notice this one, training. Notice also training is here. What is that? Well, what that means is we're logged in as a training user. Whatever username you're logged in, Linux will show you that one. That is what we need to keep in mind, guys, okay? JPS means it is just showing me a single line. The same thing, I will do it like this. Sudo JPS. It'll ask me for password, Hadoop, 123 guys. Okay, and now it shows me, hey, there is name node, data node, node manager, and resource manager. What are these things? These are the background process which are running in this Linux box, in this virtual machine. Okay, there are multiple processes running. What are these processing? Well, these are the different roles of the entities, different process which are internally responsible for the running of Hadoop is what it is, guys. Okay, and what else I can say? Yeah, sudo. What is this sudo? Whatever this JPS means, we're executing a command, a Linux command, asking it to show, Java process, and it's showing us this. When we say sudo, we are saying super user do. It's like in Windows. If you go here, start. Oops. You go to start. Come here. Go to start. You select any program. Right click that. There should be something like run as administrator. Okay, I don't have it. So here I should have something like run as admin. Okay, when I run as admin, we will pardon me. Sorry about that, guys. Sorry about the pause. Okay, so we are executing the same command as an administrator. So what is happening is when we are running this command as an administrator, it is showing some Java process which are not traditionally, an ordinary user cannot see that. Only an administrator can see that. That is what that sudo JPS sudo means, guys. We can execute some of the commands using that sudo. Here and there we'll be doing. We will see why, guys. Okay, but let's get to a little bit more basics. Notice this one. Let's clear this one. This will clear the screen. I've typed in clear, as simple as that, guys. Okay, type in ls. It will show me a list of files and directories. Okay, so it looks like that's a file. It looks like that's a directory. So another one is just type in ll. Now notice here, ll means it shows this in a kind of a detailed mode. If something starts with a D, oops. Okay, if it starts with a D, it's a directory. If it starts with a hyphen, it's a list. This is read, write, execute permissions is what it is. And here is the user training. That is a group to which they belong to. You don't have to worry about all those things, guys. But that is the size of the that directory. It says it's 4096 bytes, but inside directory you'll have more files and things like that. Then I have a Java file. We have a pig file. That is the size of that. That's the date on which it was created. Okay, guys. So that what is that? That is LL. This is a list of files. This is like, you open your Windows Explorer, you click on a folder and things like that, and you see a list of files and things like that. Okay, everybody with me so far, guys? Is that making sense? Gentlemen, ladies, can you just type in a quick Y? Cool. Now, here is another thing, guys. PWD, present working directory. This is the directory we're in. Well, because I logged into as a training user, when I log in, Linux will put me into my own directory under home training directory, right? So even in Windows, if you go into your C drive, there should be something called users. So if you log in as admin, you will have an admin directory. That is what this training directory is, guys. Okay. And let's see what else we have. Now, come here. Another one is man ls. What is man ls? Press enter. It will give you a manual. It's a documentation. It's like a help. It is telling ls is a command which will list you directory contents. It will give you more information here. If I type in space, it will give me all the options, possible options. It is giving me the manual or the documentation of that particular thing. I do a Q, I come out of that. What is the command? Man. Man means manual, guys, like a manual. Okay, manual, or give me a help of that one. What does that do? Okay, that is what man is, guys. Okay, type Q to quit out of it. Once you open that, we need to quit. Okay, LL we have seen. This will show list, detailed view of all the files and folders, guys. Okay, next one is ls minus ltr. This will show a detailed view of files and folders in a sorted manner by date. So let's see what that is. Okay, so let's clear this one. ls minus ltr. Okay, take a look at this one. Data-ds is something which was created the latest. Okay, so that was created on December 9. That is latest. Before that, December 8. This was the latest file. Before that, this one. So in other words, see that December 5, 6, 7, 8, 9. They're all sorted by date. The latest file is there. The latest file or folder is there on the below, guys. What is that? That is what ls minus ltr is. Cool, guys? Okay, few more basics of Linux. Let's see. Uname will give us the machine name. You can also say uname -a will give us more details of the machine. That's a machine name, or and it's telling, hey, it's that is probably the GNU Linux. And what else we have? That is kind of more information. It's like your computer information, guys. Okay, to be more precise, if you do a man of uname, see that it is printing the system information. We don't really need to understand all that. I386, all those things we don't need to understand. But when you say -a, it prints all the information in the following order. -p, -i. So -s will give you kernel name, node name, kernel release, and things like that. So that is what an FII, we don't really use it that much is what it is. Next, let's go ahead and clear this one. Oops. Clear this one and just type in Hadoop. Let's say, imagine I type in Hadoop 2, press enter. See this one, guys? So let's come here, just type in Hadoop 2 for sake of simplicity. I'm going to save that. Imagine we typed in Hadoop and if had it given this kind of command. What does that mean? That means Hadoop is not installed. If Hadoop is installed, this is what it will show. The moment you type in Hadoop, generally the admins go ahead and take care of installing Hadoop and things like that, guys. Okay. So what it will do is it will say, hey, there's some information. It doesn't look like that's an error. This one, it says it's complaining. Whereas here, it is not complaining. It's saying this is how you use it. That's how to verify if Hadoop is working or not, guys. Okay. And actually, let me get rid of this one. I might confuse you. Okay. So that's what I was trying to. So the next one is, let's clear this one. Say Hadoop version. Okay, notice, guys, right now we're using Hadoop 2.2.0. That's the subversion, compile and checksum and all that stuff, some additional information. But more importantly, that is version we're using. That is latest version of Hadoop. Guys, the latest is 2.7 or something like that. But but 2.2.2 is good for production and things like that. So that's why we are sticking to this one, guys. Okay, everybody with me so far, guys? Is that making sense, gentlemen, ladies? Cool. Okay, let's see what else we have. Okay, now clear this one. Let's type in Hadoop fs-ls and press enter. Notice what will happen, guys. Okay, let's give it a second. It keeps giving this warning message. You don't need to worry about it. But now notice what happened. Well, it is showing a group of files, a list of files and directories again. Where are these list of files and directories? In your first floor. What does first floor mean? In Hadoop. Okay, remember, ground floor is the apartment. Ground floor is the local file system. First floor is the HDFS, distributed file system. These are the list of files which are there in your HDFS. There's another way to look at it. See this one? Click on that Firefox. Click on that. That's the name node. Then you click on. Okay, well, so what is this one? This is our Hadoop, guys. This is another way to look at what is inside Hadoop. This is, we're accessing our first floor. What does it say? Well, that's when it was started and some information like that. So we don't really need to worry about it. Security off, say, oh, safe mode is on, I see. The reported blocks needs additional 7 blocks to reach the threshold. Okay. Okay, anyway, don't worry about that. What we do is, once we get to Hadoop, we click on browse. Okay. Let me do a little bit of cleaning up. Okay, here, guys. Hadoop DFS admin. It's causing some issues here. Safe mode leave. Okay, so now, so don't worry about the safe mode, guys. Safe mode means it's read-only mode. And when it's in read-only mode, it will not allow us to, go deep into the high HDFS is what it is. So now, if I click on this, we come to what is called root directory. That is like the my computer of your local computer, guys. Okay, and what is this? That's a file, abc.dat. That's a file. Its size is 55 bytes. The block size, default block size is 128 MB. What is this block size? Well, in this virtual machine, we have configured Hadoop so that it will split in the orders of 128 MB and not 64 MB. That is a modification date and time. That's a permission and things like that. But let's click on this. What do we have? Well, we have UP, Uttar Pradesh, Maharashtra, and things like that. Okay, what is this? This is a file here. Okay, now let's scroll down a little bit here. There are some directories here. We'll click on user. We'll click on another directory called training. Okay, so right now we're under user training. The first one is Mera Bharat 2.txt. Mera Bharat Mahan, right? So that's a simple file with a single line, 20 bytes. And here are a list of files. Mera Bharat 2, Mera Bharat New, and things like that. If we come back here, when we have done Hadoop FSLS, what is it doing? Well, notice it gives me Mera Bharat 2, Mera Bharat New underscore scoop and abc.data. What are they? Exactly this one. Where is it getting from? User training. So what is this doing? This is nothing but ls command. ls will show you a list of files in the ground floor apartment. Hadoop FSLS is showing a list of your furnitures in the first floor. In the first floor, where are these files and folders? Under my directory. User training. What is training? Training is what I'm logged in as. Okay, slightly deep there, guys. Okay, I'm going slightly deep into HDFS, but that is what it is, guys. Okay, 1 second, guys. Okay, sorry about that, guys. My little daughter comes to me and says she had a dinner, so she wanted to give me an update about that. Okay, so a little bit of fun there. Cool. Daughters are cute, aren't they, guys? Okay, I don't know how many of you have, but okay, back to Pavilion. Let's come back here. Cool, guys. So that's training. We're logged in training. You tell Hadoop, hey, buddy, and FS means distributed file system. You're telling Hadoop, and then you say distributed file system. LS means give me a list of files. What will it do? It is saying, hey, you're logged in as training. So what is it doing? It's going to the user directory. Under that, it's looking training. Under training, whatever is the list of files we have, it comes back and it gives us a list of them. Everybody with me, guys. Gentlemen, ladies. Cool. How's others doing, guys? I see only Irfan is. Hope others are also. Hope that is making sense to others also, guys. Okay. Now notice this one, guys. This is a very, very small file. Mera Bharat New. Another small file. But let's come back a little bit below. Notice this one, an XML file. It's about 1.05 GB and our block size is 128 MB. Block size is 128 MB. So let's click on that. Notice that that's an XML file. This is a file, a huge file that we'll be working later towards the end of, in one of the serious projects. We'll work with this one, guys. Okay. But let's scroll down here. Notice the total number of blocks is 9. What is happening? 1 GB approximately split into 128 MBs and it ended up splitting it into 9 blocks. In real world, if you have multiple servers, you'll see a different IP address for each block. Every block will be there on a different IP address. So we will see a different block, guys. Okay. But this is how it will look here. Are you all able to relate it, guys? These are all the blocks. The file has been split into 9 blocks. And then, because we're on a single server, all the blocks are on the same IP address. But in a real world, they might end up being on different servers, different IP addresses is what we will see, guys. Okay. So that is slightly important, guys. I want others also to acknowledge me. I see only Srujan has acknowledged them. Do you all understand this point, guys? Cool. Okay. So again, so this is the first block. This is the first block. That's how the XML looks like. Documents. That is the first document. And if you scroll down here, if I click on this one, so it got split there. It's continuing here. And like that, it will split and continue. So how do we deal with that? Well, we'll discuss that towards the end. That comes in the 10th class. We're still in the LKG and UKG of our Hadoop, guys. Okay. So actually, we're in the UKG. Till yesterday, we were in the LKG, guys. Okay. So we'll slowly go back to the 10th class, but that is what that means. Cool. So let's come back here. Let's see what this does, guys. Okay. It is the same thing. We're going to copy this. Come here. Let's clear this one. Control-Shift-V. We will paste it, guys. Okay. You can also do edit, paste like that. Notice Shift-Control-V or Control-Shift-V. Now, earlier, what we have done is we have done. Oops. This is the command we have given, Hadoop FSLS earlier. When you say just ls, it is going to the training directory and the users directory. But if you say FSLS/, this is called absolute path. What is it doing? It is going Here, it goes to the root. And then it is giving me abc.dat dc input healthcare sample data set and things like that. Notice that this is called absolute path. If you don't give that slash, that is called relative path. Okay, that's one thing to keep in mind, guys. Okay, and let's go and just type in Hadoop FS, press enter. So FS means, it will give us these other options. So that is used for appending a file, that is used for CAD for displaying whatever is inside a file, checksum. Okay, we don't need to worry about that. So, most of these things are generally used by admins and things like that. But we'll see some of these things in the coming up sessions, guys. Okay, we'll take one step at a time. I don't want to explain all these things, but under FS is a module. In Hadoop, FS is really a distributed file system. Here, from a syntax perspective, we call it as a module. Under that module, these are all the commands or the submodules which are available, is kind of what Hadoop shows us. Again, just an FYI, guys, nothing much about that, okay? And similarly, we have another command called ls-lh. So let's come here. It will also show a list of files. I think it is going ahead and sorting in maybe. Let's see that. It's probably giving the, earlier we were seeing in bytes and now it is giving us in the form of, the size of that. And okay, so let's come here. Save it here. And come back here. Okay, so Hadoop version. Have you seen this? Yes, we have seen this, guys. Okay, determine which Hadoop version we are using, as well as checksum and dates. It also shows when the release was built and by whom. That's what we've seen. Are those commands Hadoop specific or normal Linux? The school Srijan. Oh, you're asking pretty genuine and valid questions, and I really appreciate that. So don't worry about that. And they are Hadoop commands, to be more precise. All the Hadoop commands are nothing but similar to Linux commands, but we will find a little bit of cosmetic changes of adding that Hadoop FS or Hadoop DFS admin and things like that. Does that make sense, Srijan? So we don't need to be expert in Linux, but we just need to have an idea of some of the basic Linux commands. Go ahead, feel free to shoot, Srijan. Cool. So while you're doing that, let's also, looks like I have a make dir directory here. Okay. And what else we have? We got a bunch of them. Okay, so I'll come back to those commands maybe tomorrow, but let's come back here. Another quick touch of what is Hadoop. Guys, that's a formal definition we discussed yesterday. It's a framework. Remember, it converts your petrol to electricity. It supports data intensive. Generally, when we have big data, that's when we come to our brother called Hadoop, guys. Okay, what does it do? It's a distributed file system. You give big data. What is it doing? It's splitting, it's distributing the data. And what does it do? Then it will allow us to process the data. That is referred as a distributed application. It's a distributed file system. The distributed file system is also called as a distributed application. It is free. Okay, it enables applications to work with thousands of nodes and petabytes of data. Today, we may have only 1 terabyte or 10 terabytes of data. We may use 10 servers. But imagine tomorrow we are about to get about 100 terabytes or maybe 1000 petabytes, which is about petabyte of data. Oops, sorry about that. Cool. So what can we do? Well, without bringing down the Hadoop, we can just go ahead and add more servers. And you can add 10, you can add 100, or you can add thousands of servers. And we can manage petabytes of data. Who? Internally, Hadoop will manage it. We don't do that. We just go ahead and install Hadoop and leave everything to it, guys. Okay. And let's see, it was inspired by Google. So Google, they were initially came up with this Google file system and MapReduce. So all of its clients went ahead and put a lot of pressure. What's the secret of your success? That's when they said, okay, I'm going to share the secret of my success, but I'm not going to give you the software and things like that. And what did they do? They went ahead and published the papers of their brain and their heart. That brain became HDFS, their heart became MapReduce. Okay, so in other words, it was inspired from Google's way of working, guys. Okay. We only play around with those commands in real time. Yes, these are the commands you will mostly play around in real time, Srijan. And if you're familiar with these things, you'll be good to go. Some of the commands which you're not familiar, you don't have to, worry about them. And, you can be honest, and you'll get a feel of them. You'll also dynamically be able to pick them up as we go a little bit more, Srijan. Okay, so everybody okay with this slide, guys? Can I move on to the next slide, guys? Cool, great. So again, what is Hadoop, guys? Hadoop gives us a framework of tools. What's the framework of tools? Remember, one brain, HDFS, one heart, MapReduce, two eyes, Hive and Pig, one mouth and stomach, HBase. Scoop is used for transferring structured data. Flume is used for transferring unstructured data. Those are referred as the framework of tools, guys, okay? Short and sweet, one brain, one heart, two eyes, a stomach and a mouth. Everybody okay with this slide, guys? Can I move on? Cool, okay. In one line answer, what is Hadoop doing? It is helping us run applications on big data. As simple as that, guys, okay? It's free. And what is the problem? Well, the problem is the unstructured data. There's water in rivers and seas and oceans. What is water in the rivers? That's structured data. That is the database, data in the database, guys, okay? But what's happening today? People want to go ahead and get the data from the seas and oceans. What's happening? Lot of data is there. What's the problem? Storing is a problem. Analyzing it is a problem. Reading is a problem. Processing is a problem. That is the problem. What is that? The problem is with the big data. What is the big data? Well, mostly unstructured, which means you don't have a table name, you don't have a column names, you don't have relationships, constants, or anything. Yet we need to work with them, guys, okay? That is a problem. Okay, so that is the problem with the big data, guys. Everybody okay with this slide, guys? Can I move on to the next one? Cool, that's where traditionally, when people were having, big data, what they were doing, they were getting in a powerful server, an expensive server. So if you want to go from your, go to your work from home, buy a Ferrari car. But what's happening? It's limited. You can fit in 1, 2, or at the most 3 or 4, maybe, I think so, okay? Well, what's happening? That's limited amount of data. In other words, the traditional servers are limited by the, they can do only limited processing, guys, okay? So that's where comes in Hadoop. What does it do? Okay, so let me just complete this region. I'll put you on mute, I'll unmute you. So let me just complete this one, if that's okay with you. Cool. Okay, so that's where Hadoop comes in. You give it big data. The first step it does is it goes ahead and splits your data. Then it uses cheap servers. We don't need to use enterprise class servers. And you don't need to buy 10 Ferraris. If you have a lot of people going to their work, they can just use the Uber or the your Olas and get the taxis and reduce costs. Okay, there's your data. Give it to Hadoop. It goes ahead and saves the data. It also replicates the data, guys. Okay, so that is how that is what the SDR that we discussed yesterday, and that is a little bit about how Hadoop works, guys. Okay, so having said that, let me just unmute Srijan here. Okay, there you go, Srijan. Go ahead, buddy.
Hi, Navin. Good evening. Apologies if my
not a problem,
questions bothers you.
Not at all.
I'm not only source to get the answers.
Gotcha. You gotcha. Buddy.
So, see, normally in the previous slides, the historical standard way of business analytics is to process the data which we have got in the database and put forward the stats. That's a traditional way of doing it. And Hadoop is the game changer. Now we're going to see the predictable analytics to make decisions for the business. Now in this context, is this Hadoop only used for the predictive analytics using the social data, using the all the possible sources to process the data and to give insights to the businesses, or besides to the predictive analytics, does it also process the historical data and replaces the existing BI systems? Is that can you add?
Gotcha. Good question. So
sorry if I'm a bit far away, because these are the things which questions which pokes my mind. So apologies if I'm a bit.
Not a problem, buddy. That's a pretty genuine question. I appreciate that. And short answer is yes, but it may not happen right away. But in a few years, Hadoop is becoming a candidate where you would no longer necessarily need the traditional way of doing your business intelligence. You can just do the business intelligence on Hadoop itself. It might not be right away. Again, as I said, I'm probably looking at 5 to 10 years down the line. That is what will happen.
So the follow-up question is, if the business have got a business intelligence, MSBI, could be any other lightweight or hard, SAP BI even. So we can't say that those systems are replaced by Hadoop. Hadoop is just to say the process the huge chunk of data and give you the future predictions. Is my understanding correct?
It's both. You can go ahead and replace the existing, expensive, the SAP BIs, all these things are pretty expensive, according to my understanding. So you can reduce your cost. You don't really need to do the business intelligence on these expensive servers. And so in other words, that is one perspective. Another perspective is, imagine you have very highly confidential data and you cannot afford to put it on something like Hadoop, and you really need these enterprise class servers. So what you do is, you continue to use your traditional BI, and anything new you do it in Hadoop, so that you don't add additional costs and things like that. Is that making sense?
So kind of you. Thank you very much.
Great.
You mute me now.
Okay, great. Thank you, Srijan. I appreciate that, buddy. Very nice of you. So that is Srijan, guys, and gentlemen, ladies. So today's plan, we'll go ahead and stop it here. Tomorrow, we'll discuss a few more use cases of Hadoop. We'll cover a few more Linux commands. It looks like I got a few use cases there. And then we'll go into the inner workings of Hadoop, guys, okay? So tomorrow is Thursday and Friday. So probably tomorrow and day after tomorrow, we're going to focus on this one. And we'll continue a few more commands and we'll proceed like that, guys, okay? Everybody okay with the pace and things like that, guys? Are you able to follow me and things like that? Cool. Okay, guys. So thank you, guys. I appreciate you guys joining me. So we'll go ahead and call it today. You guys have a good one, and we'll go ahead and meet again tomorrow. Thank you, and bye for now, guys.